Alrighty. Okay. Well, yesterday was a medium and I'd already done, recorded, so I skipped yesterday. Today is a streak breaker. I guess it's been 3 days since the last hard. Alright, let's see if I can actually do this one. Maximum score from grid operations. You're given a 2D matrix grid of size n by n, so it's a square. Initially, all cells of the grid are colored white. In one operation, select cells of indices I, J, and color black all the cells in the jth column starting from the top down to the ith row. So it's basically like a column to this position from the top row to here. Okay, vertical column to color black. The grid score is a sum of all grid ij such that cell ij is white and it's horizontally adjacent black. It has a horizontally adjacent black cell. Return the maximum score that can be achieved after some number of operations. Okay, so there's no limit to number of operations, it's just maximizing the score. So the cells, so you're adding white cells adjacent to a black cell, so it's 3, 3, 5, so that'd be 11. 10, 7, 20, 12, 10, 11, 8, 15. Okay. Okay, this almost certainly is dynamic programming, I want to say. Almost certainly. So it's probably pretty small, yeah. Pretty small constraints in terms of the size of the matrix. So the question is, how do I do this dynamic programming? The eternal question. Every time I do dynamic programming, it's like, it never seems like I start off on some sure footing. I guess that's why it makes it hard, or hard for me. So in this case, it's always a unique set of state and state transitions that you have to deal with in each dynamic programming setup. So what is the state that I'm dealing with here? So it's either, it has to be horizontally adjacent. Can't be vertical adjacent. So it's not like this 20 is added because this 1 is black. It's because this 0 is black. So there's n rows, where n is 100. So basically, or n columns. So basically for each column I need to have a single value for the row within it that I would want to color, right? Each column would have maybe row 0 or row -1 if it's not colored at all. And then row up to 100 if it colors all 100. I guess it's 99, I guess. Maybe 0 is for having nothing, and 100 is for having it all colored. I don't know. I guess maybe that's the same, or it's very similar. So for each column, a row that colors 2. And then what? I think the issue is like the scoring is based, like the scoring of a particular cell in a column is based on both the left and right side of it. So if I iterate over possible like the farthest colored column, I don't know exactly how that scores that column. I guess I know how it scores the previous column. I really think I should focus on example 2. So in the first column, I could color the first cell, second, third, fourth, or fifth. What does it mean? 100. So what does it mean? Do I want to use, I wonder if backtracking is a thing here? Probably not. 100 is pretty big branching factor for backtracking. Probably a big branching factor. Then programming also relies on the fact that you could somehow calculate the maximal output up to a certain point. I'm not sure how you do that since it's all kind of dependent. So I think state would be what? State input. I guess it's the previous column kind of coloring. The row, this would be a single row number since the previous column is kind of given. The index that we're dealing with is the current index of the column, so it'd be index -1 or something like that. Previous column coloring, and then the state output is the maximum score. Is it called score? Maximum score up to that state. I guess that kind of makes sense. So if I'm on like this column, then there's some coloring here, and I can get some maximums. Does it make sense? How do I transition between states? So state inputs, previous column coloring. I guess maybe I should just include explicitly that there's a column index. There's a current column index, previous column coloring, which is based on just a single row numbered. There's so much dependency. It's not. What's stripping me up is the coloring could affect if I'm on this row or if I'm on this column. The coloring of the previous row also affects this thing. Also, coloring the next row affects it. Coloring of the next row affects it. I guess it only affects it in a downwards fashion. No, in an upwards fashion. Yeah, it can increase the score. And the coloring here could, in theory, add like 2 and 3 into the score. That does affect the maximum calculation. You cannot do binary search here. Seems a bit small for it to be something like some sort of heap. I think dynamic program is almost certainly it. Okay, so in this example, for the first column, I can color 0, 1, 2, 3, 4, 5. If I color 0, then I go to the next column, and then whatever I color here will affect. We should almost finalize the score here, because nothing's colored here. So whatever colors here finalizes how much of a score I can get from this column, or up to this column. I think. So if I do 9, then it scores 10. If I do 1, it scores 17. If I do the 20, it scores 22. So that's the maximum score I can get. So based on this, I score some maximum up to this column. And then what? And then I transition to this column. And then based on coloring here, I score a maximum up to this column. Does that make sense? So there's some layer of dimensionality that I'm missing here. Like if I do 0 color in this column, then each way that I colored this thing should combine with the way that I colored the previous row. I think. So I think I didn't think through the first step correctly. So for the first column, I could color 0 like it's shown. 1, 2, 3, 4 or 5 cells to black. So there's like 6 possibilities here. And then when I do this column, for each number that I color here, each number that I colored there, there's going to be some maximum that I get of the value. So say input current column, previous column coloring. So current column, previous column coloring. So if the current column is 1, the previous column coloring could be something from 0 through 6, 0 through 5 colors, 0 through 5 of these cells. So in theory, that's 6 different states. I'm at this column, 0 is colored, I'm at this column, 1's colored. And then what does that transition to? So I'm at this column, I can color 1, color 0, I can color 1, I can color 2. Is it not the column index, but actually the column index is combined with the coloring of the current column? Combined with the coloring of the current column. So current column, current coloring in this column is going to be 0 through 5 as well. So 0 with 0, 1 with 0, 2 with 0, 3 with 0. Maximum score up to the previous column. But then if it's up to the previous column, then how would I incorporate the current column? Oh my god. One coloring 0, 2 coloring 0, 3 coloring 0. Coloring 0. Then I would also need to know the previous column to that, right? Because it would need to know this coloring here, the coloring here, and then the coloring here. Like in theory, the coloring 2 columns back is variable. It's just at the start that it's always going to be 0. Previous column coloring and then previous column coloring. I'm not sure what would say that. Like pen. Maybe, yeah, I'm not sure what previous what word that would be. I mean, it's all kind of dependent. All very dependent. I wonder if there's a better approach here. Like maybe a greedy approach. It's dynamic programming approaches. disconcertingly complex. Seems like a recent problem. Nine one zero 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 one. Some sort of incremental approach. Probably not. I think for the optimal answer, I think I need an exhaustive approach. I don't think yeah, I can't see it being a problem where you can just greed your way to the answer. Greed your way to an answer. I wonder if I can just try a brute force approach. Like calculate the. Can I try a brute force approach? How long would that be? For every column, match it with every other possible. Now that'd be 100, 100 to the power of 100, I think. Yeah, that'd be 100 to the power of 100. I think that's too big. That's like a Google. 100 to the power of 100. Okay, that's when the result is the big number song. That's probably gonna be too big a number. Yeah, can't brute force this. The big number song. That's not a song. Humpty Dumpty sat on a wall. Humpty Dumpty had a big black and white ball. Do 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 do. Just can't, like, the state cannot be, the state input cannot be literally all the colorings of all the prior rows. It needs to be, or all the prior columns. It needs to be colorings of like the last column, the last two columns, some finite number of columns, not the whole n columns. That's way too complex. Can I get the state to be the last three columns? Coloring of this column, or let's say I'm at this column, coloring of this column, this column, this column. Then the score would only apply to this column. It wouldn't apply to this column yet. Quite devilish. How would that even transition? So it's the max. That's too many. That's too complex. That's 1, 2, 3 dimensions in the state matrix. In the sense that I'm transitioning for something that has inputs of 3 different values to define the state. And then I would need to transition to another state that has 3 different values. That's crazy. And those three values would be like 100 times 100 times 100 in terms of how many things there are. And that's a million. 10 to the 6. So it'd be 100, that'd be a million states transitioning to like a million states. So that doesn't sound right. That doesn't sound like I did it correctly. Yeah, that's really high acceptance rate. There's also a lot of hints. But grid score is the sum of all grid ij, such that ij is white and has a horizontally adjacent black cell. Huh. Horizontally adjacent black cell. Is there some sort of micro optimization? Micro calculation I can do? The opportunity cost. The opportunity cost coloring up to, so for a given column, if I color like 4 of them, then I get, assuming this is the rightmost column, then I get the value I don't get this value. I don't get this value. I get the sum of the values up to that 4th. So if I color up to the 4th row, I get the sum of the values up to the 4th. No. If I color this to the 4th row, then the score is going to be, it's going to add up the scores of everything from row 0, or from wherever the coloring is on this column, up to row 4 or up to the row of column to the left. The minimum between that row and this row. So if this was like, let's just say these two were colored in the previous column, and let's say there was 3 columns, or if these 2 rows were colored in the previous column, and then there was another one that had 3 rows colored to its left, then I would be, I guess nothing here matters until I color the 3rd, no, 4th. There's nothing there affects the score. Well, doesn't affect the score up to that point, but does affect future scores. So coloring the last 2 columns, coloring the last 2 columns, coloring the current column, giving the score up to the last column. Yeah, it's like, let's say coloring of the current column, the previous column, and the Actually, I'll say coloring of column C, B, and A, where C is the current, B is the previous, and A is the one before that. That would transition to another state where those things are inputs, I think. Okay. Back to a million, right? Fuck. Can I eliminate current column? Is that possible? Just have B and A? Oh, what is a dimension necessary for a state? Dimensions necessary in order to identify the state uniquely. Which I think I need to know the coloring of the current column in order to say the exact score of the previous column. Maximum score up to the previous column. Yeah. Shucks cahoots. Am I really this slow? Am I really this slow? I wish to fight my mental demons. Zero, 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 two. Color this in. I mean, I guess the simple start would be if there's any top zero in the column, you can always color the top zero. Because what difference does it make, right? You're not going to improve the score by keeping that thing uncolored, because it can only score zero. So in theory, there's like no point in not coloring these things, because whatever. Can the score be... Okay, the values in the grid are only positive or non-negative. So you can score, you might as well color these. And then the first key step or question is whether or not you want to keep the 5 or not. And here you definitely want to color these 2, this 0, these 3, and this 4. So from here, then there's no real guarantee that there's a bunch of zeros in the grid. None whatsoever. Don't know what number of zeros. What is a small optimization? For a particular cell, if you color it, the marginal row that you color in a column it marginally adds to the score on the right, assuming that the cell after that, or the column after that, doesn't color past that row. It increases score by the cell to the left, assuming that it's also white and the column to and the cell to the right or to the left of that is also white. If the cell to the left of that is black, then it doesn't include a score at all. This will incorporate the score. I don't think a greedy approach works though. And I have my strong doubts that that would work. Ah, fudge him about it. Fudge him about it. All right, tried long enough for tonight.